Hello everybody, my name is Mircea Pintea. I'm Group Manager for Technical Project Management. And today we will discuss about autonomous driving, but a little bit the history of it and the first steps, you know, the baby steps that my colleagues presented in the first couple of minutes. What I want to tell you is that somehow the basics are coming from my colleagues, the technical colleagues. Marcel Ciobanu wrote the article in the magazine, and also my colleague Alex Dumitrescu made a video for you at the end. So as a project manager, I'm just presenting the job of my team somehow. And I will start with ADAS. What is actually ADAS? Is somehow the basics of the autonomous driving. And somehow we have a lot of sensors on the vehicle trying to sense the surroundings and somehow to make some decisions in order to brake or to accelerate or to stop, eventually the vehicle to crash from something. As I mentioned, the main sensors that we have are the radar, which we can have a front radar, a rear, corner, or a back. We have cameras, ultrasounds, and also LiDAR. As functions, I will go in details for all of them, and you will see exactly how they are actually functioning. Okay, good. As my colleagues mentioned at the beginning, we have the levels of autonomy in the driving. We have from 0 to 5, and you will see that each function is having a specific level considering the complexity of the function. If we are starting from basics, literally basics, we have the front radar, and we have the function for front collision warning. For example, if you are going with a car with around 100 kilometers per hour, you have a vehicle in front of you, and the vehicle is either stationary or is moving very slow. The first step that you will receive will be a warning on your dash telling you that you should brake. This warning should be either a sound on your dash or a message. If we go as a next step, how we can extend this front collision warning, we have the actual AEB, so automatic braking, automatic emergency braking. This actually is calculating if the driver is able to stop in the end, and if not, or is not doing anything, the vehicle will actually stop stationary before an object. Imagine that still the driver is pushing a little bit the brake, but not fully, and the car is realizing that there will be no possibility to stop the car. What will happen? The car will take control and will apply automatically the full power for the braking in order to stop the vehicle before the object that is in front of the car. If we take the next step, somehow to make it even more complex, we have the AEB for crossroad junctions. Imagine that you are in a crossroad. You have a vehicle either coming from incoming traffic, so from the front, or you have a vehicle which is coming from the left or from the right. You have the video and also the radar, which is detecting that vehicle which is coming from the front, and it's actually stopping the vehicle in the end to not have an accident. Even more complex. And here we were discussing about the levels, level 1, 2, 3, 4. And my colleagues presented at the beginning that there are vehicles which are on the market with level 3, the Mercedes. Actually, that car is able to go with 80 kilometers per hour on the highway. Somehow, if I remember well, that is the maximum speed. And in certain conditions, it's able to take full control of the car. Now, imagine that in case the car is not able to stop eventually and has to do a right turn or a left turn, with the sensors that we have on the vehicle, the car is able actually to change the lane. For this, we will use all the sensors that we have on the vehicle. We have the corner radars, which are mounted in the back of the car, in the corners actually. We are using the front camera, front radar, and in the end we are giving the command to the steering to move left or right in order to avoid the accident. what I didn't mention at the beginning is this somehow these ADAS functions are split in active or passive functions, but also somehow ADAS is taking care about security, so safety in the end, and also comfort. The functions that I mentioned before are specifically for safety, so they are braking functions or evasive functions. And if we are speaking about functions that are helping us and making our life more easier, we are speaking about the comfort functions. And one of the basics for the comfort functions is the adaptive cruise control. This was somehow the basic. It was invented years ago. It is available on a lot of cars on the market. Is available on the road, and is quite robust for the moment. But if we are making it even more complicated, so not to have only the radar sensors, but also to have the video sensor, we are able to also keep the lane. So we are having the car which is able to either keep the car between the lanes or give warning that we are leaving the lanes. So we have the lane assist function, which can go from warning to centering lane keeping, where the car is actually even able to steer between the lanes and fully go forward. If we are making it even more complex, then we are speaking about the blind spot monitoring. And for blind spot monitoring, we are monitoring actually the back of the car. We are having two main sensors in the back of the car, the corner sensors. We are monitoring an area behind the car of around 3 meters, which is considered the blind spot monitoring. And with the radars, we are tracing the objects which are coming from far away. When the car actually is entering the area, which is specific to the 3 meters square in the back of the car, we are just able to give a warning to the driver, and we have a warning in the mirrors. So we have a LED, which is lighting up and informing that eventually we have something in the blind spot. If we are doing even more complex and we are using also the functions that I mentioned until now, we can speak also about the lane change assist. Here we are not changing the lane because of an emergency in the front, but somehow it's a comfort function. We are monitoring the rear part of the car, we are monitoring the front part of the car, and we are able to overtake somebody on the highway and go forward. And if we are making all of these functions together and we are putting them together, we are reaching the pilots. We have traffic jam pilot, highway pilot, where somehow we have the vehicles taking care about the road, but there has to be full supervision of the driver. How these are working, for example, traffic jam pilot. Imagine the roads that we have in Cluj, where we have a lot of traffic. You activate that function, you set up a speed, and actually your car is following the traffic that you have in front, capable to brake, accelerate as many times as is needed. Of course, it has also a safety function if there are more seconds than 10. For example, automatically it's disengaged, and in order to re-engage it, you need to press a button. For the highway pilot, something similar. The car is able to follow the cars in front of you, is able to change lanes, and is also able to detect the obstacles in front of you. We discussed about ADAS, and somehow the functions are already since a while there. Nothing necessarily new, but somehow they are the basics for driver assistance and for the future autonomous driving. If we are speaking about motorcycles, this is a completely new world. This is something completely new, and even on the market, there are few motorcycles which are able to cope with the functions that are currently developed. What do we have on the motorcycle? We have it also here. We have a front radar, which is mounted in the front in order to scan the traffic in front. We have the HMI, so the dash, where you have the warnings, speed, and any message that is needed. Then you have the engine control unit that you will see later that we need to control. We have the motorcycle stability control ECU, which is taking care about the braking. of the motorcycle, and also we have the rear radar, which is monitoring the rear part of the traffic. If we are speaking about functions, definitely we don't have braking functions. Imagine having a full autonomous braking on a motorcycle. An emergency braking that will happen on a motorcycle will definitely be the end of the rider. Adaptive cruise control is something that we have. Front collision warning, so just a warning for the collision, is something that we have, and blind spot detection also is available. How actually these are working? Exactly like I explained in the case of the vehicles, we have the target vehicle in front of us. The motorcycle is detecting that we might not be able to fully brake until we reach the target vehicle in front. And in the end is giving us a message that please brake, and is flashing a light. You will see it in the movie that I will show you a little bit later. Our responsibility is fully there, so we need to brake until we stop. The motorcycle will not stop by its own. If we speak about adaptive cruise control, it's exactly the same like in the cars. Nothing fancy, but again, it's a little bit more difficult than in the case of the vehicles. The driver is selecting a specific speed. The radar in front of it is able to monitor a target in front, and is able to select a specific speed in order to keep a safety distance from the vehicle in front. In this case, the vehicle is able to brake, so the motorcycle will brake autonomously by 30 kilometers per hour. So the minimum speed will be 30 kilometers per hour for it, and will monitor continuously the traffic in front. Another feature that we have on the motorcycle also here is the blind spot monitoring. So we have the rear radar, which is monitoring the traffic behind the motorcycle. We have two LEDs in the mirrors, and in case we have a vehicle in the blind spot, the LED will light up. If we go forward, we will see exactly how it's happening. And this is a video made by my colleague. Please look at the dash. So follow the dash, not the vehicle in front. You saw that the car was moving very fast in the back of the car, and now you see the warning. So this is the pre-warning that we really need to brake, otherwise we risk a crash. Again, a pre-warning in order to brake. Here my colleague will do the demo for the ACC. So my colleague is setting up the ACC. He activated the ACC, and we are tracing the vehicle in front of us. The target speed now is 70 kilometers per hour, but the vehicle in front is having 63 kilometers per hour. So we are keeping the safe distance from the vehicle in front of us. You will see that my colleague will accelerate in the end. We have the target speed of 90 kilometers per hour, and the vehicle in front is following him with 67 kilometers per hour. And you see another vehicle which is entering in front of the motorcycle. So in that moment, we had a second target, and we needed to brake. What happened? Happened that there was also a blind spot part, but I don't know why it stopped. We had a demo also for the blind spot. No, it was not a crash. We managed to stop in time. It followed the new car. It followed the new car. It stopped, and afterwards the car accelerated, exited the target that we had, and we had to follow again the red vehicle. But I don't know why the video stopped. I presented to you some basics, really basic functions. So ADAS functions that you see today in your vehicles. In order to go forward, beside what it was presented until now, fancy ECUs which are able to cope with a lot of calculations, sensors that are ultra performant in order to detect the environment in front of them. We had also to consider the GPS location and also the car-to-car communication in order to have the future autonomous vehicles. Any questions?
Marian.
You presented many solutions. What happens, or how the hardware solution is comprised? I mean, each sensor has its own processing unit, or they are split between video processing and sensor processing and so on, and the radars.
Yeah, that's a very good question. So when we discussed about the ADAS functions, we had the camera is somehow the main. Usually it's scanning the road in front of it, it's making the decision, and it's receiving information from the radar, which is creating the objects that it's detecting around it and giving those objects to the camera in order to take the decision, to brake or to steer or to other things. And of course, without fusion, you cannot do this. Also, when we discussed about advanced driving functions, where we had the traffic pilot or the traffic jam assist, highway pilot, those also functions are functioning with fusion between multiple cameras and multiple radars. The decision usually in current days is happening on the camera level.
Does it use a dedicated processor?
Honestly, I don't know. But somehow we are sending from radar, for example, to video direct objects. So we are telling them that there is a specific object. The camera is doing on its side the processing of the image, actually separately, and comparing if there are those objects or not in the field. If they are confirmed, then we have to take a decision. But the image processing is done separately. Radar is computing everything separately, and afterwards you combine them into one information. Please.
So about the ACC function for the motorcycle, you mentioned at some point that there is a limit of 30 kilometers per hour, so that that will function. Why is that? And also if there is a maximum limit.
Maximum limit depends on the capability of the radar. So the radars are today able to cope with higher speed at even 210 kilometers per hour. The point is that you need to detect something very far away. Imagine at 200 kilometers per hour how many meters you are going in 1 second. And the minimum speed is coming also from the possibility to brake without falling from the motorcycle. At 30 kilometers per hour, there is a safe speed that you still are able to stay on the motorcycle. And also we are speaking about a manual transmission. Imagine that if you have an automatic transmission, it would be easier. In case of the cars, it's exactly the same. If you have a manual transmission, the ACC is able to brake minimum to 30 kilometers per hour, because otherwise then the engine will stop. The same thing is happening also on the motorcycle. If you have an automatic transmission, usually the ACC is able to brake up until 0 kilometers per hour. So that's the minimum that you are able to do it. And on the motorcycle, beside the gearbox is also a safe speed that you are still able to stay on the motorcycle.
Okay. Thank you, Mircea.
Thanks.